we're talking about piecewise functions and greatest integer functions, and we want to graph piecewise functions, write piecewise functions from a graph. So here we have three expressions, and here we have the restrictions on the domain for each one of those expressions. So the first thing that I want to do is I want to make sure that I pay attention to the restrictions on the domain. So the first restriction I have is x is less than or equal to -1. So I want to make sure that I have that graph. So I'm going to make this b5, -5, -5, and 5. And I want to graph my restrictions. This is not what you have to do, but this is just what I like to do. So here we have x is equal to -1. And my other restriction, so here is x is less than or equal to -1. Here is x is less than -1. So these are both restricted at the same location. And then we have one more restriction at x is equal to 3. So 1, 2, 3. So I want to graph that one as well. Now I can take a look and I can see that -x minus 4, so y equals -x minus 4, and I can think about graphing that. So I can start with what would that mean if I substituted -4 into that equation. And so if I go to solve g of -4, and that is equal to, we'll substitute that in, -4 minus 4. So when we go to solve that, we get, or evaluate that, we get 4 minus 4, and so that's equal to 0. So we still get the point -4, 0. However, when we go to evaluate this, it says, so we can go ahead and plot that. So here we get the point -4, 0, which is right there. And now we know our slope right here is a -1 slope. So when I go to graph that, I can start from there and I can go down 1 over 1, down 1 over 1, down 1 over 1, down 1. No, that's as far as I can go right there. And so I know that I have to have a circle here on my limit. And now I pay attention to my inequality sign. And my inequality sign says that it should be included. So I can make that be a solid dot. And then I want to draw the line that connects the two. So I have one of the three graphs drawn there, and that is y equals -x minus 4, and that's this graph right here, that part of the graph right there. Another example that we can look at is we can look at g of x is equal to -2x plus 3, and let's evaluate that. We can evaluate that at g of 1. So g of 1 is equal to -2 times 1 plus 3. And there we get -2 plus 3. So then we get that is equal to +1. And so we get the ordered pair 1, 1. So over 1, up 1, we get a point right there. And we know that our slope is -2. So then we can go down 2 over 1, down 2 over 1, and we get there. And then we look at our inequalities. So here to the right, it says that 3 is included. So 3 should be included. So we'll make that be a closed dot there. Over here to the left, it says -1 is not included. So if I go up 2 over 1, up 2 over 1, now right here, this should be an open dot. And if we look, we should have a closed dot and an open dot should be stacked. We should never have 2 closed dots stacked. So then we can draw the line that connects these two. And then we got one more expression to evaluate. And that is x minus 2 is greater than 3. So we can substitute in 4. So we'll evaluate g of 4, and that is equal to 4 minus 2. And 4 minus 2 is equal to 2. So then we get the ordered pair 4, 2. So 4, 2 right there. And our slope in this case is +1, so we go up 1 over 1. And we can go back 1, down 1. And here, 3 is not included, so we should have an open dot at 3. And then we can draw our line going up and to the right. So our domain here, we have x must be greater than 3, not equal to, just greater than. That's why we have an open dot at 3. And then for our blue function here, we have it goes from -1 to 3. The -1 is not included. We have an open dot. -1 is not included. The 3 is included because that is a closed dot. And then for our first function here, we have x is less than or equal to -1. So -1 here, we have that, and that's a closed dot, so that is included.